Hello friends, today I am going to deliver the lecture on the topic Ionic Equilibria. In a previous lecture we have completed the halogen derivatives of alkane in part first. Now today the fourth chapter from part second, that is the Ionic Equilibria. Now before starting this we must know what is meant by the Ionic Equilibria. Now the equilibrium between ions and unionized molecules in the solution is called as the Ionic Equilibria. Now suppose we have to take one example. When acetic acid is dissolved in water, then it gives acetate ion plus H plus ions. Means in this example the equilibrium between ions and unionized molecules in the solution is known as the Ionic Equilibria. Now when acetic acid is dissolved in water, then it gives acetate ion and H plus ion. This is the ionized molecules and this is unionized molecules. The equilibrium is established in between these ionized molecules and unionized. This is called as the Ionic Equilibrium. In 11th standard, we have seen the principles of Ionic Equilibria, and by using these principles in 12th standard we have discussed about we have to explain the equilibrium constant and the concentration of ions and unionized species. Now before starting this Ionic Equilibria, again we must know some concepts. Now first of all, first concept is the electrolytes. What is meant by the electrolytes and what is meant by the non-electrolytes. Now the electrolytes means the substances which gives rise the ions when dissolved in water are called as the electrolytes. Now take the examples for the electrolytes. Suppose NaCl, when it is dissolved in water, then it gives Na plus plus Cl minus ions. Means electrolytes are the substances which when dissolved in water, then it gives ions, that is known as the electrolytes. Now the non-electrolyte means the substances or which do not ionize when it is dissolved in water. Now that is known as the non-electrolytes. Now these electrolytes are again classified into two types depending upon the extent of ionization in the aqueous solution, and there are two types of electrolytes. First one is the strong electrolyte, and second one is the weak electrolyte. Now strong electrolytes are those which dissociates completely, which when dissolved in the water. Now the example of strong electrolyte is NaCl. When it is dissolved in water, then it can dissociate completely, that is Na plus plus and Cl minus ions. And weak electrolytes are the electrolytes or the non-electrolytes are those which do not ionize and exist as a molecules in the solution. Now that is known as the non-electrolytes, strong electrolytes and weak electrolytes. Means weak electrolytes are the electrolytes which when dissolved in water, then it do not ionizes or it can ionizes to a small extent. Now that is known as the weak electrolyte and strong electrolytes. Now the example for weak electrolyte is again acetic acid. When it is dissolved in water, then it is acetate and H plus ions. This is the weak acids. Now by knowing these concepts, strong electrolyte, weak electrolyte, the next important part is the degree of dissociation. next concept is the degree of dissociation. Degree of dissociations means it can be denoted by letter alpha. Now this degree of dissociation of an electrolyte, the degree of dissociation of an electrolyte is defined as the fraction of total number of moles of electrolytes that dissociates into ions when dissolved in water. Now it is denoted by letter alpha, or mathematically it can be written as alpha degree of dissociation is equal to number of moles dissociates divided by total number of moles. Now that is the alpha, number of moles dissociated divided by total number of. Now by knowing this degree of dissociation, the next important part, what is meant by acid and base, because up to the 10th standard we must know what is by acid and base, but in 12th standard the different scientists put forth his ideas for the acid and bases. Now the first concept is the Arrhenius theory for acid and bases. Arrhenius theory. Now the basic idea for the acid and bases according to Arrhenius theory is the aqueous solutions. According to Arrhenius theory, acid is any substance which contains hydrogen and which gives H plus ions when dissolved in a water. Now that is known as the acid according to Arrhenius theory. Take down the example. Now HCl, when it is dissolved in water, then it gives H plus plus Cl minus ion. Now this HCl when dissolved it gives H plus ion, therefore it is a Arrhenius acid. Now according to Arrhenius theory, base are the substance which contains OH group and which when dissolved in water then it gives OH minus ion, that is known as the base. Now take down the example. Sodium hydroxide NaOH, when it is dissolved in water then it gives Na plus plus OH minus ion. Now this is the simple concepts according to Arrhenius theory, that is the acid and